Hi, everyone. I'm Jackie Jenkins, Marketing Manager here at Senceive. Welcome, everyone, to our April webinar. This is all about data management and data integration for an effective monitoring program. I can see that we have a lot of people here today, a mix of all different types of companies and sectors. I'm sure this will be a really informative session and relevant for everyone. With some great advice on how you could get the most from your monitoring data. We're really lucky to have Bryn Smith here with us today, not only because he's given up his evening to present this webinar. He's based in Australia, so it's his evening time, but also because he has a deep knowledge and understanding about Senceive products and solutions. He's been with the company since 2012. And of course, it's been involved in a lot of key projects and product launches as well. Just a housekeeping note, as the webinar goes along, please feel free to type in any questions into the question box, and we'll try to get to all of them at the end of the webinar for question time. So yeah, over to you, Bryn. Take it away. Thank you.
Right. Hi, everyone. So let's see. We're talking today about integration, as Jackie said, and there's a bit of a discussion sort of talking around our cloud infrastructure, how it fits together and how you can best connect into it. Just a few words about me. Jackie gave an introduction, which is lovely. Thank you. My background is a software and electronic engineer. I'm not a surveyor or civils person or whatever, but I've been around at Senceive since 2012, so I've got a bit of a picture of what's going on. Prior to, in a past life, I was working as an embedded software engineer in the automotive industry, but I've been I was CTO at Senceive based in London until 2018, and then since moving back to Perth, Australia, I've been the technical director of Senceive. I've had my fingers in a lot of different pies, and just some examples of what I've been into at Senceive is all the current flat mesh platform. There's some early prototypes there that you can see from the early days. Introduction of monitoring hubs, which is a technology we often use in tunnels and other tricky data connection environments. A lot of web software, and I was also the main developer on the Nano firmware, which was a derivative of the current flat mesh platform as well. There's a whole lot of other stuff that I've been involved in. This is just to give you a rough idea of what I've been doing. So today what we're talking about is automatically sending data collected by your sensors to another data processing system. So going from your sensors, from what the readings your sensors are collecting, and getting that into another system for a variety of reasons. And why would we want to do that? Often it's to combine data from different sources. So you might have total stations on your site. I mean, this is probably one of the most common things that people need to do this for. We've got total stations all over the site, so we introduce tilt sensors as a great complement to total stations, but you don't want to have two different data platforms that you're looking at all the time. You might have satellite data that you're combining in. You might have manually collected readings, and you want to see everything in one place for reporting, alerting, all sorts of other reasons. You might also, depending on your project, you might need to send data out to other systems for contractual purposes, to enable your stakeholders to do clever things with the relatively expensive and high quality data that you've collected. So, for example, you might need to send data out to a stakeholder database. An example of that was on the Crossrail project in London. They ran a central database for all monitoring data on the whole of Crossrail called USIMS. And so the idea being that you'd automate the data transfer to USIMS instead of having to manually upload it once a month. you might want to send data out to a BIM platform so that people can integrate, look at the monitoring data in the context of the structure, or SCADA platforms if you're in an industrial environment. So today, the things we're going to talk through are just a bit of an overview of how the Senceive cloud infrastructure works. So the data processing systems that we have operating on the internet. A quick rundown of the data export options that you have, and some guidelines on how best to choose which of those options is best for your project. So first of all, talking about the cloud, and Senceive.io is a relatively new component in our cloud infrastructure. This is something we've been talking about for a few months now since its launch, and essentially what we have here on the left-hand side here, we have our sensor nodes talking to a gateway, and they pass data to Senceive.io. And so you've got a flat mesh system here and a GOAN system there. Senceive.io handles some pretty basic fundamental stuff, like it handles data flow management. So where does the data flow from Senceive.io? Where does it flow out to? And also handles device configuration and management. So when was the device last seen? Can we send some configuration changes down to the device? All that kind of thing. Senceive.io then has its complement, our long-standing visualization platform, data visualization and alerting platform, WebMonitor. And WebMonitor handles the other side of the other aspects that are important to this endeavor, which is data calculations. So dealing with the calculations for virtual sensors, baselining, data visualization, so plotting graphs, making it possible to interpret the data easily, and handling alerts. So being able to set data alerts, receive SMS alerts, email alerts, that kind of thing. WebMonitor can do all of that stuff for you. And so this is a little bit more of what it actually looks like. In Senceive.io Cloud, which is the product that we're talking about in this instance, the gateways talk to various input modules. So in the case of GOAN, it goes through a LoRaWAN network server, but essentially it's talking to the input module here. And they feed data to the event stream and the diagnostic log. And from the event stream, we can draw data from the event stream into into WebMonitor. And WebMonitor's backend service does some processing. It can send email and SMS messages out and store it in the database. And also you can access it through the web, and it includes in the title there with WebMonitor. So let's have a look at what this data looks like at each stage. I'm dealing here with a data sample from a flat mesh node. It's a tilt sensor, and it's generated a bunch of data samples, and one of them happens to be an x-axis tilt reading. That's what we're looking at here. Looks a bit garbage, but we'll go through it one line at a time. It's pretty straightforward. So when at Senceive.io, at this point here in the system, in the event stream, I mean, it's actually a binary format, but this is what it looks like internally. The source device ID, we've got the MAC address of the node. This is the node address. You're probably pretty familiar with this stuff. And the edge device ID, we've got the ID of the gateway. So we know which gateway the message came through. There's the event time. So when was this data sample taken? And that's always going to be, at this stage, is always going to be a UTC. We're not doing any time zone conversions at this point. And there's some information about the data sample here. So we've got a sample number. This is just a serial number tagged by the node as it generates the sample. We've got a port ID and channel ID, again, just telling us which part of the node it's come from. And then there's the sensor model. So this tells us the type of the data sample, the value, and the units. And this is all we really have on the event stream for this particular tilt sample. Not very useful for doing alerting So a lot of other things that need to happen there, but it's the fundamentals. It's the raw data. It's about as raw as you're going to get. So what happens after it's in the event stream, the Senceive event stream? It gets passed to WebMonitor, and we'll see what that looks like in a moment. After we talk about what WebMonitor does. So WebMonitor will go in and apply the baseline. It will do any virtual sensor calculations. So that's aggregate sensors like twist calculations or strain on props type calculations. It'll also do sensor chain calculations if necessary, so generating longitudinal calculations. It'll also link that tilt reading or whatever other reading to its relevant temperature reading. And that's if you want to do temperature correction later on, it's a lot easier if you've got a link to that temperature reading already made. WebMonitor also assigns the data sample, or it finds a mapping through the configuration to a particular location on a particular site. So you're not just dealing with the node ID anymore, you now know where it is with a friendly name that you've given it. So you know it's on, embankment XYZ, node number 37 at chainage 1100. It'll apply a time zone offset, so we know what the local time is at the time of that reading. It'll generate any data alerts, as mentioned before, and there's a bit of other stuff which I haven't bothered to put on the slide because this is all the key points anyway. So what does the output of all of that look like? Well, a sensor sample. This is looking a little bit more human readable now, you can see. So yeah, as I said before, we've got a site and a location, probably a better example. Platform 3, location TS456, we know what that is. We've got a node ID, the same node ID as we had before, surprise, surprise. But because it's in Brussels, we know that the time zone is UTC+1, and therefore the time is 8:50, not 7:50. The sensor models changed a little bit, but it's still basically the same thing, sensor model and sensor type. And the final value, you can see that's had a baseline applied to it. It was over 1 before, but it was probably the case that when that node was installed, it wasn't completely level. So we need to subtract its original reading, the baseline reading, from that to get the final value. Aha, but this is a trackbed sensor. So we're also doing some calculations. In this particular case, we're doing a Cant calculation. It's about as basic as it gets. So we've now created not just a tilt reading, but we've now got a Cant reading. So this is goes through the calculation. We know the spacing between the rails on this particular track at this particular platform. And so with a bit of trigonometry, we can calculate the beam displacement, which is the name that we give in the case of a Cant calculation. We use a beam displacement calculation to give us a final value of 3.066 millimeters. And then this value can then be used for alerting, reporting, whatever else you need, and it can be exported from the system as well. So we've talked about data going out. Let's talk a little bit about configuration changes, just briefly, because that's the other string to Senceive IO's bow, fairly relevant to this topic, to this conversation. So Senceive IO has an API and has a website to allow management of the devices and data flows. So there's a website component and an API component. Obviously, users hit the website, and automated systems or other systems like WebMonitor hit the API, and you can send configuration updates down to the nodes through either of those mechanisms. The event stream is output only. It's just an outflow of messages through a message broker connection to WebMonitor or to other systems. So let's move on to data integration. How do we get your data into other systems? So there's four main integration points, four main points at which you can integrate your pull data from to integrate into your system. We'll go through each of them in turn. So there's a new bit here that I've drawn in here called Senceive text file writer. This is a separate little utility which can be installed locally on a machine. So we'll talk about that one in a moment. But the rest of this stuff here is pretty much what we saw before. So first of all, there's the raw event stream. So the main data outflow of Senceive is the event stream. It's designed as a low latency, high efficiency outbound connection. If you control your own platform, you can modify the code, write a plugin, whatever it is, to just have to connect directly onto this event stream. And that's basically what we've done in WebMonitor. You can have multiple receivers on a single stream. We've had a couple of customers also do this with their platforms already, and it's quite secure because there's TLS encryption required on all connections. So we've got a little example, a couple of screen grabs from one of our customers. This is a customer in the Netherlands who has a specific project, quite a large track monitoring project, and they've chosen to draw data directly from Senceive instead of using WebMonitor, and they've built their own visualization platform specific to their project because then it does exactly what they need. The other little block that I put in there in the diagram earlier, text file writer, is just a small utility which you can install on your own machine, and it draws data once again from the event stream of Senceive. It's pretty easy to set up. It's designed to be quite efficient so that it can handle multiple streams, multiple sites, lots of data outflow, high rate data outflow across multiple sites. You can customize the output format to suit your target system. I've got a couple of, I've got some screenshots on the next page to give some idea of that. And you can control the file rollover interval, and that gives you control over the latency. It's a trade-off between the number of files that the text file writer generates, the number of files you need to manage, versus the number of versus the latency in the system. We've tested this to operate on Windows 10 and Windows 11. We will take inquiries for other platforms if needed. I expect it would work without modification on a Windows Server system as well. And just to give you a little insight into what you can do in terms of output control. So the way this works inside the tool is that you can customize the format string using a format template, so you can write your field codes in with formatting codes if necessary. And as you type in here, it automatically updates the sample output, so it helps you to build the output as you go. And to help further, there's a field code builder built into the same into the same page, so you can pick your tag and your format, and it will give you the field code that you need to give that sample output. So it's I think it's quite smooth once you get used to it, but and we've got a couple of standard formats available as well. So now that we've talked about the Senceive event stream and text file writer, options from WebMonitor, which you might be a bit more familiar with because they've been around for longer. There's the FTP push out of the back end. The WebMonitor can upload files to an FTP server periodically, adjustable from 6 minutes to 24 hours. There's a menu of, from memory, about 8 or 9 different output formats available. We know that a lot of people use FTP still because it's a lot easier to set up, but we do support FTPS and FTPES for secure connections. We can only configure one destination server per WebMonitor site. So if you need to be able to send this data out to multiple places, you probably can't do that solely with FTP Push. You might need to mix in a different approach as well. And the fourth option is to use the WebMonitor API. This is an endpoint that you can poll from your system. We recommend a minimum call gap of 1 minute, and the queries can get a bit slow, up to sort of 2 minutes on large sites. So that does limit the data rate that you can get out of the system. It's quite a powerful query language that you can use, but it can be a bit complicated to get started with. We've got some documentation and some examples. We do have dozens of customers using this, and not just that, we also know that Trimble 4D Control worked with Trimble to support the WebMonitor API, the GraphQL API natively in that software package. So we've got other customers, users of T4D, who are using the API essentially without us knowing about it. And again, this is another more modern, secure approach than FTP because encryption is required everywhere. So how do you choose? We've got 4 different options there. Let's see if we can quickly run through the steps that I'd suggest for figuring out which way to go. So first of all, the big decision is to go whether to go with the integration into Senceive.io or whether to go in with integration into WebMonitor. And this is the series of questions that I suggest looking at. So Senceive.io, just to run through them, only buffers events for a limited time window, 7 days. So the system you're feeding into needs to have long-term data storage, and it always needs to be switched on and receiving events. If you switch it off for a fortnight, you're going to miss a week's worth of data. It doesn't track and apply baseline levels. As you saw before, as we stepped through the cloud, the baseline was applied at WebMonitor, not back at Senceive.io. So you need to have some baselining functionality available. It doesn't convert from vibrating wire frequency or millivolt counts. So for externally attached sensors, essentially, you need to do that conversion from frequency or millivolt counts to engineering units in your visualization platform. It doesn't have any arbitrary calculations. So if you want to do beam calculations, Cant, twist, cross-level, set up longitudinal, all that kind of stuff, then you'll need to do that in the visualization platform. And finally, Senceive.io doesn't send any alerts. So if you're missing any of these in your target system, any of these things on the right-hand side, then you're probably better off integrating at the WebMonitor level. So that point that narrows the scope a fair bit, I think. Going through these questions gives you a really good idea about whether you've got what I'd consider a fully capable visualization and alerting platform or a limited visualization and alerting platform. So to summarize the 4 points, I think this is my last slide. So if you've got a fully featured platform and you're heading to integrate it with Senceive.io, the 2 options are natively integrating it at the event stream, and that requires your platform to support Senceive.io natively. So you either need to build that support in, or you need to buy in a platform that supports that already. If it doesn't support Senceive.io natively, you might be able to go with text file writer. It's quite customizable. Most systems out there can handle a text file input, so give text file writer a go. If you've got a limited platform, a feature limited platform, or if you've got an existing project, then integrate at WebMonitor level, or integrate at WebMonitor, and FTP Push is still a very well supported and commonly used approach for integrating. If your platform doesn't natively support the WebMonitor API, that's probably where you're going to end up on FTP Push. If you've got a platform that supports the WebMonitor API natively, for example, if you're using T4D from Trimble, then perhaps you can use the GraphQL API instead, and then you don't have to deal with all of the files, the flat files littering your system and the FTP server. So you can integrate the API server. All right, I think that's about it. Thanks very much for your time, and I think we can go to questions now.
Thanks, Bryn. That was great. Yeah, great summary there, and in particular those last 2 slides I think were really, really good overview of what to use when, in case people are confused. You know, the possibilities are endless right now with Senceive.io, so sometimes people don't know Senceive.io or WebMonitor, and I think that was a really great summary. So thank you. We have a few questions that have come in already, but feel free to type in some as we go along here. So there's been a few questions around Senceive.io. Now the first one is about changing reporting rates and other settings remotely through Senceive.io, because you talked a lot about, you know, the data flow management. So maybe you could touch a little bit more on the device management side of Senceive.io.
Sure, I'll just flip back. Sorry, I did a horrible thing of flipping back through all the slides.
That's okay.
Here we are. So yeah, that's really where this API component comes in. So if you want to set up your visualization platform or any other system, regardless of whether it's integrated into your visualization platform or some separate system entirely, to send commands out to the nodes, you can do that through the Senceive.io API. So your external system, or you can log in and do this manually, can go in and submit a change request for reporting rate or network settings or whatever you like. And then Senceive.io will send the message down to the node and retry it and make sure that the message gets through. And you can track that progress on the API or on the web.
Great, thank you. And just while we're on the topic of Senceive.io, someone has asked, does Senceive.io store data?
Alrighty, so yeah, back to this one. Yes, it does, but only for a time limit, only for a limited time. So we keep a lid on the amount of data that Senceive.io can keep, because the visualization platform or WebMonitor, including WebMonitor, is intended to be the long-term storage for your data. So the event stream here, which is the main data outflow as discussed before, this will keep data for 7 days. And it's kind of all mixed in together for a particular device group. For a group of devices in Senceive.io, it's all interleaved together, but so it's a mix of, you know, data samples and neighbor reports and status reports and config messages and all the rest. It's just in one big stream for that group of devices. It's easy enough to filter them out. This is not a problem, but after 7 days, those messages start getting cleaned up and deleted by the system. If we need to go back and look at the history to try and figure out what's going wrong with it, you know, trying to figure out whether there's problems in the hardware or in the data flows, then we do have some diagnostic logs available. These are not the part of the outflow. You can't take your diagnostic logs and funnel them out the event stream, because they're not really stored in a way that allow you to do that. The diagnostic logs are currently kept for 6 months. We're still evaluating the amount of data storage that we need to keep that for 6 months, but that's certainly our current plan on that. So this component here this component here is intended as a forensics type approach. You can go back into the system and figure out what went wrong and when.
Thank you. Okay, one more question for you, Bryn. Someone's asked, can text file writer produce files with the CSV extension?
Yes, so I didn't show it on the screen. Format controls, you can set the extension to whatever you need. And if you need to change the separators between field codes on the line in the format in the format window, you just change whatever text is there. You press tab, it'll put a tab there. You press space, it'll put a space there. Press a comma, it'll put a comma there. So it's certainly easy to produce CSV files with text file writer.
Great. Thank you. I think that's it for our questions. I don't see anything else coming through. But of course, you can always email us at info@senceive.com if you have further questions, and either Bryn or someone else will get back to you. Just so everyone knows, a recording of this webinar will be sent to everyone probably tomorrow. And do keep an eye out for our May webinar, which we'll probably be announcing in a couple of weeks as well. We're trying to do these monthly now. So thank you everyone for joining, and of course Bryn, thank you for your time and giving up your evening. We appreciate it. Thank you so much everyone. Have a good one.
Thanks. Bye.
Bye.